All right. So about a month ago or so, I received a bug report. I believe the site is actually fixed now, but I actually have a relatively good idea. I actually remember what the bug was in the first place, which is probably a good thing that I remembered. Um, when we absolute position something, so we say position relative on some container, let's give it a width and height as well, of 100 pixels and a height of 100 pixels. Give it a border so that we can see it. Lovely containing block there. And then let's say that we have something that is position absolute width, say 20 pixels, height 20 pixels, and give it a background being line. There we are. When we position absolute something like this, we can set all of the insets. So we set left 0, right 0, bottom 0. And then if we set our margins to auto, this will center that element right in the middle of our containing block. The bug is, let me add some text here, hi. The bug is that if this is a button, and this button has an auto width and height, this centering doesn't happen. And really this button here should be centered right in the middle. So what's going on? So let's dive into my Chromium branch. We will create a new branch. Let's call it out of flow bug. Hooray! Let's compile first. And I forgot to do a compile, so this might take a couple of minutes. That's unfortunate. Let me check firstly. Oh my lord, I have 2 people watching. That's hilarious. Unfortunately, let me build something that is a slightly smaller target than blink tests. I'm also not sure how compiling is going to go with also running the video capture software, but we'll cross that bridge when we get to it. So if I quickly bring this up in Firefox, oops, Firefox is very, very large. You can see that they center the button right in the middle here compared to us. So this is clearly a bug on our side. Unfortunately, even with a very, very powerful CPU, building Chromium does take a little bit of time. For me, it takes probably about 30 to 40 minutes to do a clean content shell compile. And this is a 16-core CPU, so it's pretty beefy. I don't have this hooked up to, a lot of Googlers will have what's called Goma, which is a cloud compile, and most other people that are building Chromium will be using, a lot of other people that are using building Chromium side companies will be having, some distributed build system, which will speed this up significantly. Let me also just copy this into let's call it button.html. just so that I've got locally on my machine, on my Linux VM. This is my personal Windows box, and I'm doing development using the Whistle 2 stuff that Microsoft just released. And they did a really, really good job with it. So we will use it. Slowly, slowly getting there. Can I zoom in the terminal? Yes, let's do that. Oh, terminal really didn't like that. Let me resize it to try and refresh. Is that more readable, Elliot? Okay, while that compiles, let me increase this. We'll talk a little bit about the code. Where are we? This is a ginormous comment for something that is very, very complicated. So fundamentally, all absolute positioning code ends up with this function here. We don't care, in Blink at least, we don't care if this is a replace element, so if it's an image or something like that. We don't care if it's a table. We don't care if it's a regular block. It all ends up into this function. So you can see the inputs to this function are massive. We have a lot of different things that we need to consider. So it's actually very, very complicated. This function also handles both axes as well. So it handles the width axis and also the height axis. So this is why, instead of something called, margin start length or margin end length, this is why we don't have like margin left length or something like that. This is all, axis agnostic, if you will. So this is why we have like start and end. So whenever you see start, think left. Whenever you see end, think right. So we've got the two margins, so start and end. We've also got the insets. So this is going to be, if you specify top 0 or top 10%, in our case, left 0, right 0, this is going to be these two lengths. We've got the static position offset. Let's not talk about that because it's very, very complicated. We've also got the available size. So this is going to be the width of the containing block. And for this specific example, it's going to be 100 pixels. Let's see how our compiler is going. Halfway there. I should have really compiled beforehand. So the first thing that we do is a lot of our code uses optional values. So typically, you might think of, your margin, is only going to be, some float value, for example, or some int. But often in layout, we also need to represent, a null value as well. And this is what, all of our values are represented in optionals. So this is similar to like a Haskell, maybe monad, I think it is. But basically an optional can be null or it can be some value. So whenever we pass the margin here, if it's not auto, so if something is like margin 10 pixels, we're going to set it to something. If not, if it's auto, it's going to be null, for example. And we do this pretty much for all of the interesting values. So we convert this to an optional for our margin start. We convert this for our margin end. And the same thing for the inset start and inset end, is that we need to know if it's auto or not, rather than inspecting this length each time, we just convert it to an optional. The other thing that this does is that this will resolve something that's like margin 10% to say, 10 pixels. So we resolve all the percentages. If it's something more complicated, like a calc, for example, 10 pixels, 10 pixels plus 10%, this is going to go and go, oh, I know how to resolve that 10% now. I'm going to be 20 pixels. So this minimum value for length function will basically normalize it so that we only need to consider if it's auto, so it's going to be null, or it's going to be some pixel value that we can then mangle around, for example. Let's see how we're going here. We are getting there slowly. Got 2,000 complement units, just over halfway. In absolute position code, this is fundamentally the equation that we're solving. So this is a really good comment. We take the inset start, so this is our left. So if you imagine, I'll just like write this out. If we've got, say our left being 0 pixels, if we've got some margin being 10 pixels, we've got an unknown size. We've got, say margin end of 10 pixels. And we've got some inset end of say like, right is like 20 pixels, for example. This needs to equal our available size. So this is going to be the width of the containing block. So here, if we substitute all of these values in, we can work out the size. So it'll be 100, 100 minus 20 minus 10 minus 10 minus 0. That will give us the width of 60 pixels here. So this is fundamentally what all the absolute positioning code is doing. It's taking this equation, and if we don't know a particular set of variables, we try and calculate them. And we do it in such an order that it's always going to be consistent between browser engines. So the first thing that we do is if we don't know our left, if we don't know our right, and if we don't know the size, then we'll fall into this branch, and then we'll set the margins to 0, for example. And wash, rinse, repeat. If we know all three, then we can compute margins potentially. So it's basically a whole set of glorified, basically fairly straightforward if statements. If you're just getting into Chromium code as well, a really interesting thing to note is the layout unit class is actually very, very interesting. So browser engines do all of their layout calculations using fixed precision. So what is fixed precision? Instead of something being a, say float, for example, so float is floating precision. We've also got ints, which are just ints. Fixed precision is similar to an int, but instead of representing whole numbers, something that's like fixed precision will be representing a fraction of a number. And so we use 1/64. So whenever we have like a layout unit, has some hidden value inside of it, whenever this is equal to 1, this is actually equal to 1/64. I think Firefox uses 1/60th. That actually has some nice properties in that 60 is divisible by lots of different numbers. So it's divisible by 5 where we aren't. It's also divisible by 3 where we aren't. I think HTML previously used 1/100ths, which also has some nice properties. We use 1/64ths primarily for speed and simplicity. We need to be a little bit more careful about how we redistribute additional space, but fundamentally that's not that complicated. Let's see how we're going. We are very, very slowly getting there. Let me just check if there's any questions or whatnot. All right, let's clean up this terminal. There we are. All right. Do the old recompile again, just so that we can see how much longer we've got to wait. Shouldn't be too much longer. So what I'll be doing next is basically, oh, that's really annoying. That's like not a balanced arrow. Let me fix that. When this finishes compiling, the first thing I'm going to do is jump into a debugger, and then I'm going to set my breakpoint effectively on this function, and then to see which branches that we take. So this is going to be compute absolute size. I'm very, very sorry. I should have compiled before I started streaming. All right, we are building some XR stuff. We are now linking all of the different libraries. Linking. All right, we have content shell. Fantastic. Okay, so the first thing let's do, let's run our test case. I think I said it was button. Hooray! And we can see we've got our button. Content shell is just like a very, very small toy browser for us. It has an URL bar, it has refresh, back forward, but that's about it. This is basically like Blink plus a little bit of browser Chrome, just so that we don't have to build all of Chrome to do changes. So it's very, very useful in that sense. I'm going to pass an argument that some people hate, some people love, which is single process. Let's fire up LLDB. Let's break on, what was the function name called again? Compute absolute size. Compute absolute size. And unable to break. Let's run it. It's found the breakpoints, which is good. So we typed that thing in or copied and pasted it correctly. Sometimes this process can be a little bit slow just because it needs to scan the whole thing. This is a whole bunch of stuff, and we fit the breakpoint. Hooray! So the first thing that we can do is we can print our layout tree. What is that variable called? And let's go up. Let's go up. What is that thing called? Let's do up again. There we are. Print node info.node.box show layout tree for this. Okay, let's see where we go. So our margin should be auto, so we should skip that branch. Other margin should be auto, let's skip that. Why is it can't find my identifiers? That is very, very strange. I'll need to debug this, work that out later. I think I've got a relative idea of what's going to happen though. So we know our insets, so we should know that inset start is going to be that. We know our inset end, so we resolve that. We are branching into this branch now. So we know our inset start inset end and our size. Oh no, we don't go there. So this is fundamentally the problem, is that the code, where did compute absolute size go? Buttons are special in that this variable shrink to fit will be set to true. Various elements are shrink to fit. Sorry, Elliot. Various elements are shrink to fit by default. So tables, for example, they won't expand their whole width, the whole width of the containing block by default. And the same is true for buttons. So this is shrink to fit variable is going to be true. So it's going to be set true here. Where's compute absolute size gone? Here we are. The thing is that we typically, in this code currently, we are only applying that auto margin rule when we hit this branch here. So when we know our inset start, when we know our inset end, so if we know that, we know our left is 0, we know our right is 0, and if we also know our width, then we would hit this branch. So if I put a debugger for a second, let's fire up the button thing. So if I was to set the, where's button.html gone? So if I was to set my width to something, so width, say 10 pixels, suddenly we'll hit that branch and it would center. But basically the problem is, that we need to drop into this branch here if we are also shrink to fit. So is shrink to fit, or we've got our size specified. Now the problem here is that this assumes that we know our size ahead of time. So you can see here, if we know our inset start, we know our inset end, and this assumes that we also know our size, we can then compute how to distribute that extra margin space. The problem is that we've now dropped into this branch is shrink to fit true, which we won't know our size yet. So we need to compute it. So let's have a look for where we compute is shrink to fit variable. I also named that variable wrong. Let's set let's make content shell instead of blink test because that's slow. Is shrink to fit. There we are. So all I've changed so far is I've just changed this branch to is shrink to fit true. If I run this as is, this is going to crash. Bada bing, bada boom. Because we are trying to, basically we are trying to access this size variable where this is currently null. It's currently null-opt. So we need to basically compute our shrink to fit size. So this is how we typically compute our shrink to fit size. Let's grab that piece of code and let's throw it up here. So we'll go if we, really it doesn't really matter, if we go is shrink to fit, we compute our is shrink to fit size. Let's check all of these variables. Is table, that's true. Compute min max size is func, that's fine. Available size is fine. Computed available size is something that we'll need to determine. Yeah, so our computed inset available size is basically, it's the space available after we've taken account for the insets. So the available size minus the inset start minus the inset end is going to be the computed available size. That one's fine. And then fundamentally, we don't know these margins yet. So we need to assume that these margins, are zero. So let's just pass in an empty layout unit. So this will then compute our size, and then we should be fine. Let's find out. Let's make this. Let's see if we get any compilation errors. Let us run this again. So you can see we've got our new code in there. Let's run this again. Bada bing, bada boom, it is centered. Hooray! There's a few things. So typically when we are working on a patch like this, there's a few things that we end up doing. We need to write a test, and also we can simplify this code, I'm pretty sure, quite significantly. This isn't really, we're doing a lot of calculations, twice, for example. So for example, I can pull this computed available size out of this branch, and we are also using it here. So if I do computed available size here minus star size, that simplifies that calculation a little bit. Let's have a look. The other thing that I like to do is decheck. So if we're not shrink to fit, like this should obviously be true. But it's good to often just spell this out so that if someone is ever refactoring this code in the future, and they hit this gcheck, they something we would hit this anyway down here, but it just helps future-proof us that a little bit more. Compute. The other thing is that the coding style that we have in Chromium is that if a function parameter isn't immediately obvious, we'll often just duplicate it here, just so it's very, very clear to the caller that this is what I'm passing in. And that should actually be about it. Let me format this. There we are, looks a little bit prettier now. And then let's see if we need any comments here. I also want to spot check the rest of the code to see if there's any other cases that would fall into something similar. I wonder if, I'm hoping that we called this like margin space previously. So I think that looks, yeah, that looks about it. Let me just spot check. So then we fall into this path where we set any unknown margins. This looks pretty good to me. Okay. Oh, hilarious. So I think if we had also just a little bit of like a min width here, it would then magically center. Hilarious. Yeah. Okay. So the next thing that I want to do is write a test. External WPT, CSS position. Let's call it position absolute. Let's call it button. Let me see what everything else in this directory is, the naming structure. So this directory is the web platform tests directory. You can see wp2.fyi is a whole bunch of tests. This is contributed by effectively anyone. What happens for us is this is reflected, this is basically mirrored into the Chromium repository. So whenever I add a test here, it will get committed to the Chromium repository and then it will sync up with the web platform test repository, which is on GitHub. So let's do CSS position, absolute. I mean, I could just label it center. What's this one like? Yeah, let's do that. Let's call it this. So let's call it position absolute center 005. That will be fine. Let us grab this demo that we had. So now we've basically, there's a few ways to do tests like this. The way that I sort of prefer is the style of test, where we're basically just trying to make it a green square. So let us do width 200. We need to keep it a button. Let me WSL file. I don't actually have my history there. There we are. That's like some other tests I'm working on. Let's hide you out of the way. Okay, let's go to that directory, third party, web tests. I messed something up. Nah, can't select that. So far, so good. There we are, and position absolute. Center 005. There's our test. Fantastic. Okay, so let's make this into a green square. So let's do background green. We need all of that top right left bottom auto. Let's actually just do left and right because that's all that's really required here. We'll keep the margin auto on all sides. Let's give it an explicit height. And then we need something inside of it that actually makes it 100 pixels wide. So let's do a width 100 pixels inside of it. What do I need to reset? It is currently 116. There's some padding that I need to reset and a few other things. Okay. Okay, and let's get rid of the border as well. Hooray, okay, solid green square. Okay, let's shift this over, margin left. What do I want? Negative 50 pixels. Okay, and then if I load this up now in content shell, let me blink web test external, WPT, CSS position, position absolute 005. Oh, center was called 005.html. We have that green square, fantastic. This is what we currently render, which is off to the left. Let me just view source here. Let's copy all of that. We need all of that stuff. We need all of that. Bada bing, bada boom. Get rid of that style. Matching that, let's add in the correct bug number. A button element with centered with auto margins. A button element should be centered with auto margins and insets and 0 insets. Okay, that is the description of what we're actually testing for. Where did our content shell go? Here we are. Let's refresh you. Fantastic. That's now our test. We can see that we obviously failed this test in our current implementation. I wish I could open this up in Firefox to verify that that passes there. I'm 99% sure it does, but they don't support this like special WSL file path yet. I'm sure I'll get around to that. Okay. So that is effectively the patch. Let's add this file. Git add that file, git status, git commit. This is position, fix centering of button with auto margins. The final check that I'll do is I'll run that test. CSS position, absolute center, what did we call it? Position absolute center 005.html. Sure. Let's see if that runs. Oh, I actually need a compile blink test for this. That's why it's yelling and screaming at me. Yes, I did need blink tests. Thank you. 1,000 compilation units. How are we doing for time? We're at about 3:30. Cool, fantastic. That test case is pretty good. Let's have a look at this patch. Do I need to comment that? Not really. That should be fine. So the other sort of cases that I'm now thinking about are sort of similar test cases. So we will now fall into this branch for if this is a table. So a table is always shrink to fit. So if we go back to our like toy test case in button.html, let's make this a table instead. And then let's run the content shell. Sure. Yeah, so this, let me have a look at this. I suspect we have a, let's go back to button.html here. Oh, I haven't done proper markup for tables. This is always the danger with tables. Let's do, instead of a table, we will do, instead of doing a table, we'll do this, and then we'll do display table instead. Yeah, so this I would expect, I would expect also to be centered. Let's see. Oh, there is. Firefox only does it in one axis. That's probably a bug on their side. So let's try this test case out now. Don't need that. Actually, let's leave that compiling, and then we'll switch to the content shell. Come on, content shell. What are you doing? I suspect the whistle to's X server or something like that is not having fun anymore. Let me restart the VM. There we are. Yeah. I know I just killed you. Content shell, button.html. Hooray, there we are. And now, so this has accidentally also fixed this case for tables as well, which is now centered. So we should probably also write a test case for that as well in each axis. So let's do third party blink web test external. Actually, let's do third party blink web test external wpt. CSS disposition, position, absolute. What did I say it was? Center 005.html. Let's make a 6. And also we'll make a 7. Okay. I just want to check that that is indeed broken. Yeah. Position absolute center 006.html. Let's open up that here just so we can see it. Where did you go? Oh, you're at the wrong one. There we are. That is 005. We want 006. Let us, instead of a button, we'll make you a table. Let's see what you look like initially. Yeah, so with tables, I'm also going to need to give this inner element a height as well. Tables are a little bit special. Oh, I need that not to be a table. I want this to be a display table. Okay, there we are. I'm pretty sure our new code will pass us a table. And then let us open up 007. And what I want to test for 007 is basically the vertical instead. So now I want a width of 100 pixels, a height of 200 pixels, a margin, let's say top of negative 50 pixels. Instead of left, I want top and I want bottom. Margin auto is fine there, and then I want an explicit width of 100 pixels. Whoops. Cool. And then this needs to have a height. Cool. Did I completely make this ugly? Eh, not really. Width 100 pixels, height pixels for clarity. Okay, so that was 006. Let's have a look at 007. What have I done wrong here? I didn't add display table. This is still a button. Display table. Div. All right. And you can see it is not centered when it should be. So now we will go back to right. So let's have a look at what those two look like. We don't need all of those flags. That'll just confuse people. Let's have a look at what 007 looks like. Fantastic. Let's have a look at what 006 looks like. Oh, I pressed 7, 6. Oh, my typing isn't working. Fantastic, that also now passes. All right, so let's add those two tests as well. Let's get status, get add 007. Oh yeah, I didn't update the expectation line. Position absolute center 007. My whole computer is not happy compiling, trying to index all of the files and also streaming at the same time. So that's awkward. Let's stop you just so that you can have a little bit of time to index. There we are. Double 007, that can be there. Okay. Let's clean up that. That should be a div. Let's amend that commit. All right. So we've got a change, which is relatively straightforward. We've got our first test case. Button element should be centered with auto margins and zero insets. Button, a table should be centered with auto margins and zero insets. Display table, bada bing, bada boom. Cool. And that is basically the patch. So like most patches in Chromium, this ends up being a lot of tests that we need to write. Typically, a typical change will, likely have more tests lines than we will actually C++ code. Depends on the feature that you're working on, but for this particular thing, we ended up with a 3 times, blowout basically. We wrote maybe 5 lines of code, and we ended up with, call it 8 times 3, 25, 30 lines of code. So let's run the web tests, CSS position. What did I call these? What were these calls? Position, absolute, center, Let's run those. I think that will, I might need to throw a wildcard in there. Yeah. I didn't find any tests. Let's just do, okay, we can run 235 tests. Something is unhappy with my test setup. We won't worry about that. So what we'll do now is upload this to our code review system called Gerrit. This runs a whole bunch of pre-submit tests to make sure that I've got my patch formatted correctly. It will also check for these. What was the bug number? Here we are. Let's write our commit message first. Previously, if an element was shrink to fit tables buttons by default, tables buttons, etc. We would into a branch where we would fall into a branch where we didn't consider auto margins. This resulted in elements not correctly centering. This patch makes shrink to fit elements same branch as if we had a size specified. Cool. So that's our commit message. Basically, a good commit message always has the problem, and then the problem, why it was broken before, how you're fixing it, and then if anyone does code archaeology on those lines of code, they can see what I was trying to do previously. We'll git seal try, and then this will basically run a whole bunch of trybots now. So this is now my patch in Gerrit. You can see patches uploaded, and we should soon see a whole bunch of trybots running. Maybe we won't. There we are. There's the first one. All right. The thing that I also noticed in this code is that we can potentially do a little bit of cleanup here. Let's do out-of-flow bug-2, set upstream to out-of-flow bug. Compute absolute. Yeah, so I'm a little bit suspect of this code here. So basically what this code is doing is that at the very end of this, we've worked out what our left, our right is. We've worked out, a whole bunch of things. And then we will apply the min-max sizes. So if, the min-max sizes here is if we've got, min width 80 pixels, for example. So if our size was previously, say 50 pixels, this size would be 50 here. The min-max sizes would be 80. And so this constrained size would end up being 80. And so if this size didn't equal the size that we had previously, we'll rerun the whole thing. And this is why we had that behavior that if you set like a min width or a max width on the button, would suddenly center the margins. So now I'm just going to do like a little bit of an experimentation to see if we can sort of simplify the. Basically, I want to be able to remove this branch here. It might not work out, but let's see how we go. Because all of the code more or less falls into the same structure, is that we either need to compute our shrink to fit size, or this branch would be something like size equals min max sizes. We'll basically apply the min max sizes. So let's try and do that. Let's have a look. Yeah, so let's grab U. It's going to be very, very similar to all of this. Let's just comment you out there. So I'm going to create a lambda function up here for now, which will just encapsulate just allow me to play around a little bit. Let's just say resolve size, we'll call it. Let's just capture everything. We're going to need to pass is shrink to fit, I suspect. This is going to return a layout unit. This is also going to need, we're also going to need to pass into a layout unit of computed available size. We need this thing. And then the only difference here is that we may not know our margins. So we're going to have to use a trick where we do value or layout unit. Value or layout unit. And then, yeah, so then we want to basically unit size. We shrink to fit, otherwise we do stretch fit effectively. We're going to need value or here, layout unit. That value or layout unit. Do I want to simplify that? Not really. We don't need that dereference of size. Okay, let's see if this makes sense. So basically I've extracted out resolving this size, but then I've also applied the min-max sizes, min length and max length sizes here as well. So let's find all these shrink to fit sizes. Size equals resolve size is shrink to fit true computed available size. Let me just double check that this is the same. I highly suspect it is. Yes, that should be fine. Okay, that's the first one. This is the code that we just wrote. So all of that should be fine. So let's do star size equals, we can just do size equals resolve size. Is this one, we don't need to pass in that explicit true. Computed available size. There we are. The next one, actually, let me just grab that. Where are you? Here we are. There you are. This one, we do want to force this is shrink to fit thing true. That one's all fine. And the same here. We want to force that to be is shrink to fit true. This one, we don't. We just want to pass in is shrink to fit. Okay, and then I suspect we don't need this branch anymore. Did that make things cleaner? Probably. We'll see. Let's format this just to see. Let's try and make it. This is too high up, and I forgot a semicolon. So let's pop this here. To do write comment. Okay, oh, we forgot that comment, that comma. There we are. Semicolon, rather, whatever that thing is called. So the reason that so what this value or does here, I probably should explain this, is if margin has already been set to something like 10 pixels, it'll just keep it as 10 pixels. But if it's currently like null, then it will set it to 0. So basically just like normalizes it in case we don't know the margin yet. And so this is important for the branch that we were just playing with, the branch down here. When we resolve this size, we don't necessarily know what the margins are yet. They're auto margins, so we just assume that they're 0, and then we can go ahead and work them out after the fact. There may be now more opportunities to simplify this a little bit more. I suspect that one of these branches is now a little bit unreachable, but I'm not 100% sure. Okay, but so this patch is just basically just a small refactoring just to simplify things a little bit. Let's try, I think all I need to do is add a comment about what resolve size does. Computes the size. Applying the this should be else if the bug that I've got here is yeah, so the bug I have here is I need to call this resolved size. And I'm playing a little bit with fire here because else if not size else dcheck size that has value. This is just extra dchecks just to make sure that when I run the trybots on this, everything works out. So I'm pretty happy with that. Let's have a look at what ended up being. Let's get CL format that. Let's just compile it again, just in case I've messed something up. I have, what have I done? Oh yeah, okay, vim set make. I can't spell dcheck apparently. There we are. What's my next thing? That needs to be resolved size. There we are. And let's make that again. For this particular change, I'm not 100% certain that I've done everything correctly. So what I'm going to do, I'm not 100% that will even commit this, but basically clean up, try to simplify out of flow logic. Basically what I'm going to do is upload it to Gerrit, run the trybots, and effectively see what happens. We might find that I've broken something. We might not. We'll find out. But this is generally, when you're working on a big project like this, um, if you're working in the code and you see an opportunity to refactor something or simplify it even further, that's almost always the right thing to do. If you never, simplify some logic, if you just keep on growing and growing and growing, you end up in a bad spot. We've already uploaded it. What am I doing? Git CL try. Okay, so this is our other patch. Let's check on how our first patch is going. This is a new patch which tries to simplify a bunch of logic. It's looking pretty good. You can see we are basically basing it off the other patch that we've done. And I want the old stuff. And you can see all of our trybots running now. So if we go into this trybot here, we may have broken something. Nope, that's just random failures. Very interesting, Blink web tests. So we have broken something. So this is something that I'll likely debug later. We are failing a dcheck. Fantastic. What have I done wrong? Let's have a look. Let's check out our original branch. Git check out Earl flow bug. Let's build this. And then let's drop into LDB. I may have gotten my GN flags not working 100% correctly, but this will at least allow me to work out where I'm breaking something. I see. Yep. The okay. What has happened here is if we are a so there's two types of elements. There is okay, so what I'm going to have to do, there's two types of replaced elements. They're confusingly named, and our logic in here is a little bit dicey, which is why we have dchecks everywhere. but a replaced element is something like an image or a video, um, and it basically adheres to a whole separate other rules. Um, so the reason why they're dechecking here is that size here, um, the size variable actually has a value. So we actually need to do something in reverse. So let us go into ng absolute utils, compute absolute size. Where did we go? We went, where did we decheck? We dechecked if we want if not size. And then if I switch this decheck to is shrink to fit, this is actually fine. This will still be true. Cool. So let's compile. So what I was saying before. So replaced elements are a little bit special. Buttons and things like that are what we call like semi-replaced. And so the bug that we're falling into here is that when we've got this like is shrink to fit variable, this is set for both like fully replaced and these semi-replaced variables. So you can see here. So this function basically returns true for images, videos, as well as buttons. But for replaced elements, we've already got this size set. So we pass in the replaced size here, and we like explicitly set the size to that replaced size. It can't be anything else. So that was the bug. This is why we put dechecks everywhere, to make sure that, whenever we do some small refactoring, we're going to hit our problem. Let's quit out this. Yep. So that's all that we expect. Let's run that test to make sure it doesn't crash. It still crashes. What have I done? We are now, let's open up LLDB again. If you take one thing away, write dechecks everywhere for complicated code like this. It will save you a lot. It will basically save you, shipping regressions into code. There we are. Okay. F6, what's 6? Yeah, we did two checked. Okay, yeah, we can't have that decheck, unfortunately. ng absolute utils, let's see. Uh, da, 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 what did I call it? Where were we? We were here. Yeah, so that decheck basically doesn't mean anything now. Let's compile this. Let me have some water, because I'm actually starting to lose my voice. I don't usually talk while I code. Let's run that test that we're crashing again. Bada bing, bada boom. Hooray. All right. That should be, let's amend this. That should be about it for this thing. Let's do a quick check just to make sure that we haven't broken any of our tests that we were messing around with. Yeah, so that's fine. That's fine. That's fine. Cool, fantastic. Let's Yeah, I amended right. Get CL upload. It's running all the pre-submit checks again. Fix dcheck. We've uploaded it, so let's give it a try on all of the trybots again. So this will actually, did we get to any of the crashes here? Yeah, so you can see, we had a lot of, tests fail, basically. So now you can see it's cancelled all of the current trybots that we had running. It's basically said, oh, the CQ doesn't need the build anymore. And that's because we uploaded a new patch with a fix. And it's going to, and now I've just said, hey, run all the trybots again. So it's going to run all the trybots again here. And we'll see how we go. So now I'm going to perform a rebase update. Because we had a branch based on top of the current, the branch that we're currently working on, we basically need to port that fix to the sort of cleanup branch that we're just sort of experimenting with. So where are we? Here we are. So you can see here we've got very, very different code. What do I want to do here? Yeah, so basically I just want to take the new stuff here. Oh, get rebase skip and get rebase update. Okay, now I've actually got the merge conflict. So you can see, we had our logic, which we changed, which was not size, do the compute shrink to fit size. Now we've basically got to put that fix into resolve size, which we added. So let's delete all of this, just make it resolve size. Let's go up to resolve size. So now, this might get a little bit hairy. If not size and is shrink to fit, we want that. I'm just playing around with how I want to structure these branches. Yeah, I think that makes more sense. I'm now less confident about this branch, but what we will do is run the trybots on it, and this should catch any errors that we've done. This dcheck doesn't mean anything now. When a dcheck is something like this, which is basically the not of the if branch above it, it's not super valuable. Yeah, let's do that. Let's compile it. I've completely messed something up. let me just add this. And I can see what the whole patch looks like. I've definitely messed something up with that patch rebase, but let's upload bug 2. Yes, let me just try compiling this. I've copied and pasted something incorrectly. Let's have a look. What is it complaining about? What is it on about? Oh, I forgot a brace. There we are. That's what you're complaining about. Okay, good CL format. Amend. Good CL upload. Rebase. We didn't really change anything. And we will run the try dots on this again, git cl try, and then let's have a look at what we did. Cool. So this is our patch again, looks very, very similar, except the thing that we did is we changed this to not size here. The nice thing about Gerrit is that we can see the difference between patch set 1 and patch set 2. So we can see, the very, very small logic change that we did and carried over. So we will see how we go. This first patch probably hasn't had enough time. It's probably got like another half an hour to run on all of the tribots. The final thing that I sort of wanted to quickly play with is there's a little bit of basically whenever we've got asymmetry in layout, that's typically a bad thing. So you can see here that like, let me open up this button thing. Let's get back to our original example. So this button here, its behavior is asymmetric, and this is also like asymmetric in Firefox as well. In the sense that like it like shrinks to fit in one axis and then it stretches in the other axis. And this is typically a bad smell. It's typically, not like you expect things that work in one axis to also work in the other axis. This may be because of just, web compat. There's some websites now that depend on this stretching behavior in this axis, and we can't change it. So one other thing that I'll create a new branch, upload bug 3, getting 3 patches out of this. One thing that I want to just quickly try is setting the flag is table. So you can see when we compute the inline dimension, so this is like the width, for example, we treat a table and this node should be considered as replaced as shrink to fit. But when we compute the block dimensions, so this is the block dimensions, so this is the height effectively. We only consider table. So if we change this to is, it should be considered as replaced here. We'll delete this. We'll compile this. Let's fire up content shell. We just need that button. We don't care about that test. So yeah, the test still passes. Obviously, that's good. Let's do button.html. And we've got dcheck failure. That could be why. What is this dcheck failure? Again, this is why you should write dcheck failures, like dechecks all of your code whenever possible. Yeah, right. This could be why that browsers behave this particular way. So what is happening here? Let's drop back into the debugger. My slightly broken debugger because I don't have symbols for some reason. Oh, I haven't been looking. Oh, great. Someone what? I think. Uh, Glad to see that you're enjoying it. Okay, here's our dcheck. Let's go up, 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 up. Yeah, so here we've got this dcheck that whenever we hit this, we already have an inline size. Compute out of flow block dimensions. We've hit that branch because now we are shrink to fit. We are computing the absolute sizes here. And here, right, okay. So the problem is, so we've got like this codependency here in the code. Right, so this fundamentally, this variable here, is it that variable? Where is this? Up, up, up. Yeah, so we've sort of, whenever you have here, where we like try and determine the inline size or the block size when we don't know the inline size. This here needs to be true or false rather. Can compute block size without layout. Okay, what we need to do is we pop this up here. Oh, let's edit this. What we need to do, I'm not explaining this because it's somewhat a little bit complicated. But I'm just basically, this might get a little bit dicey. This has got other larger problems with it. This will likely get rid of our immediate problem. Where did that just go? Let's create the debugger. We don't need to know what's going in there anymore. Button.html. Oh, we're still dechecking. Did I compile? Yes. Oops. Oh, that's the wrong test case. I'm just seeing if these trybots have reported anything interesting now with that change. Nothing yet. So we're hitting a very, very similar decheck. This is probably intrinsic block size func. And then we're hitting that. Okay, I'm just stepping through the debugger just to see where we're going with this. Go into our new function where isShrink to fit, we compute that size, we step into there, and then we're not hitting that. I just want to check if this like actually does the I've probably done a very, very simple Boolean logic error here. This is more or less what we need to do. This might not be exactly right, but I'll need to think about this a little bit offline. A lot of the time with layout code is that you sort of need to mull on it, over the course of a day, just because things are, very, very complicated. Yeah, so now you can see we have, centered the button as now symmetrical on each axis. So I'm not really thrilled about you know, it does make it symmetrical. It does mean that when you can now center a button in both axes, um, there is, this codependency problem that we've got to deal with now. So I basically will need to try and make sure that that works correctly. Um, but yeah, I will probably also, I'll just upload this as well and run it through just Tribots, you know, just to see what this looks like. Just to see, what tests are depending on our previous behavior. Is it something that we can actually change? Is it something that we want to change? I'm not really sure. Uh, is center block axis shrink to fit testing? We'll upload it. Yeah, I can show you the source of button.html. Let me just sorry, Corpan. I don't know how old that comment is, but I will show button.html very, very quickly for you. Oops, I forgot to set upstream. Set upstream to outflow bug 2. We'll deal with that later. Cat button.html. Let me format this a little bit more. So we've got containing block, that's width, height, 100 pixels, position absolute, all of the insets are 0, and then margin auto. So basically, in the inline axis, I suspect, we are the ones that, this is the bug that we're solving at the moment. We should be centering. In the block axis, it appears that us and Firefox are stretching. Hooray! Not so old comment. I'm kind of curious to know what Safari does here to see if they do something even more interesting. Let me just open on my Mac here and quickly type out the test case again. Width 100 pixels, height 100 pixels, border solid, button, what did I say? Style equals position absolute, inset 0, background lime, and then margin auto. And I need a position relative. Yeah, so it looks like, yeah, so that's our behavior. What does Safari do here? Safari stretches in all axis, which is very, very wrong. Yeah, so that part of the spec is the problem with like semi-replaced elements like buttons um, is that they don't necessarily follow all of the same rules as the like true replaced elements do. So I think arguably this change is correct that we now like uh, this arguably is the correct behavior that we should be centering the block axis, but all implementations currently stretch, um, which I'm very, very suspicious about. Um, it may not be even web compatible, but I'll run it against the tribots and see what happens. Um, I suspect there's a lot of behavior differences also with like tables not centering in both axes and things like that. Um, but did I upload this? Good. Uh, oh, that's right. I was going to do a rebase update and fetch to get it on the right path. Hooray, there we are. Okay. Git CL upload. Sure. Let's try this and see what tests break. Um, cool. All right, we'll leave it today. I just want to check on the first patch to see if it has any more tests successfully run to see if that was actually remotely successful. I've just realized that my stream might be dropping out just because of bandwidth. Cool. Um, all right, I will leave it there. I hope folks learned something. Um, if you like this, let me know. If you didn't like this, if you think there was areas that I could be more clear, or something like that, let me know. Um, hopefully this is useful to folks if you want to look at Chromium development at all, or if you just like to watch random people struggle with browser code. If people found it useful, I'll likely try and do it again. All right, have a good one.